02 pass with maximum minimum value. So we are giving m times n integer matrix grid, and we need to return the maximum score of a pass starting from 0, 0 to m minus 1, n minus 1, moving in 4 cardinal directions. So these 4 cardinal directions just means the top, down, left, and right. Yeah. So for example, 8, 4, 5, 9, it is a 4. It means we're gonna return the minimum value because inside the pass. But this 4 should be maximum of all the paths. Yeah, so let me just explain it here. Yeah, like this path 5, 4, 5, 6, 6. So we're gonna return a minimum value of 4. But there might be any other paths like that. Yeah, so it can be 5, 1, 2, 4, 6. But we're gonna return this value of 1. Yeah, and also we should know that the maximum value is also fixed. It should be 6. And in this path, the maximum value is also 6. Yeah, but we need to return a minimum value. Yeah, so the minimum value should be 4. It's not 1. Yeah, we need to. So in this problem, it just means we need to find a path, and we want to find the maximum value, the minimum value inside the path, which can reach from the top left corner to the bottom right corner. But this value should also be maximized. So as you can see, this is a maximum and minimum problem. Normally we can use a binary search to solve the problem. Yeah. So let's check a similar problem. So there's another problem that is similar to this one. Maybe you did this one before. It is called swim in rising water. So for this problem, we're gonna find a path, but we need to find the maximum value. So for in this example, the maximum value is 16. So if it is 16, we can reach from the top left corner to the bottom right corner, as you can see. Yeah, but this is gonna be the maximum value. But our problem, we need to find a minimum value inside the path, but this minimum value would also be maximized. Yeah, as you can see, it's similar to this problem. Yeah. Now let me just copy the code. Yeah, from the swim in rising water to solve this one because they are really similar. Yeah. Now let me copy the unified template, and let me copy the template for solving the swim water problem. Yeah. Yeah, because I don't want to write so many duplicate code. I just want to change a little bit and make it work. Yeah. Now we are going to solve this problem. Let's just use this example. Yeah. We are going to find the minimum value inside the path, but this minimum value should be maximized. So we can use a binary search to check it. So here is the binary search template, and for the value, because the maximum value is 10 to the power of 9, so it is not R and C, so we're gonna change it to 10 to the power of 9. Yeah, and here is the binary search template. So we're gonna first find the middle value. Yeah, middle. We're gonna first find the middle value. So if it's like m, it means if this m is just like a threshold. Yeah, I will explain this check m later. But if this check m is possible, it means it might be a smaller value. Maybe we've already found a 1, 2, or 3. For this example, it's return 3. Maybe we've already found a 1. It is possible because all these values is more than 1. And we're gonna record the result should equal to m. And we're gonna try a bigger value. So here it should be changed to L should equal to m plus 1. And similarly, this R should be equal to m minus 1. It means if we are guessing a bigger value like 10, it is not possible, so we're gonna guess a smaller value. So this is why R should equal to m minus 1. Now let's try to, I'm not going to explain the template of unified because you can find many unified templates in website, in different algorithm website, or you can just Google search it. You're gonna find many different Python unified templates. So I'm not going to explain here, but I'm going to explain the basic call function of this tag. So this tag is just like a threshold function. We're going to put the m inside as the threshold. Now we are going to check it one by one. So for r, so here I prepared the unified. So uf should be uf r times 6. So this is the unified. I'm going to turn this 2D array into a 1D array. Now I'm going to check one by one. So for r in range r, for c in range c. So here it can speed up a little bit. So if r equal to 0 and c equal to 0, here I need to change it. So if this grid r c is less than, yeah, before it is more than. So here I would to check if it is less than the threshold, because each of the values should always be more than or equal to threshold. So if it is less than threshold, I'm gonna return false. So here, less than or equal, I need to change to more than or equal. Yeah, because if it is more than or equal, I'm gonna continue. I'm gonna continue the loop. I'm gonna continue the unified. I'm gonna unite like 3 and 4. If the threshold is 3, so 3 is more than or equal to 3, 4 is more than or equal to 3, so 3 and 4 will be connected. Now, here, I'm gonna check the next node. So here, the grid row and column should be more than or equal to threshold, and then I'm gonna connect it. Yeah, so in this way, if the threshold is 3, all those values inside the path will be connected like this one. Yeah, and I'm gonna return this 3. So finally, I'm gonna check if this top left corner and bottom right corner is connected. If it is connected, I'm gonna get the record of this result and return this result. Otherwise, I'm gonna continue the binary search. Yeah, as you can see, I didn't change too much code. Basically, I just changed this r value. It means the maximum value, and I also changed the threshold from here. Yeah, basically I just reverse the directions. Before it is smaller and equal, now it is more than equal, and here similarly more than equal. Yeah. Now let me just run it to check. As you can see, it works. Now let me submit it to check. As you can see, it works, and the speed is not so fast. Yeah, because unified normally takes more time than directly the BFS or DFS, but at least it works. Yeah, I think 4 seconds is still okay, but the time complexity is m times n times log 10 to the power of 9. Or you can make this number to a smaller number, but there's no difference. Yeah, for example, you can just check the maximum value of all the values inside the grid, and you can do it like this. So you can use a maximum, and inside it would be a maximum of the item. So for each of the item inside the grid. Now let me run it, but there will be no difference because for the binary search, log 10 to the power of 9 or log 10 or log 100, there's no difference. As you can see, the time is nearly the same. Yeah, so this is the unified plus binary search solution to solve the problem. Thank you for watching. See you next time.